Good afternoon, everybody. Thanks for coming. Derek's going to lock the doors in the back so no one can leave. My name is Greg Neagle. I work for Walt Disney Animation Studios. This is Walt Disney Animation Studios. And this photo was taken last week, and I just discovered yesterday that Disney Animation was founded 96 years ago yesterday. So it's pretty old. When you assemble for a big group picture like this, the person that's running, that has the camera says, make sure you can see the camera lens. If you can see the camera lens can see you, right? That's not exactly true in my case. It saw my eyes, at least. Yes, I'm not the tallest person in the world, and oh well. So where were we? Let's start with Python, which is the first word in the title of this talk. Since we're going to be looking at Python, that means there's going to be a lot of code. I apologize for that. I've made the text as large as I can. If you just came in, sitting closer to the front is going to be better. Anyway, Python. You might have heard that Python 2 is end of life in January 2020. If you haven't heard that, Python 2 is end of life in January 2020. What does that mean? Well, the Python Software Foundation, which is the sort of the governing body that runs the open source project that is Python, has announced that Python 2 will have a code freeze in very early January. They'll follow that up with a official final release of Python 2, which should be 2.7.18. And then after that, nothing. It's over. That will be the curtain call for Python 2. So if you have an active Python project, you really should have been moving it to Python 3, but this is kind of like your last do it now kind of panic moment. What about Apple? Apple is also telling us some news about Python. As part of the release notes for Catalina, they note that future versions of macOS, whatever that means, will not include scripting runtimes by default. So that will include Python, probably Ruby, Perl, Bash turns out to be in that list as well. And they're definitely saying that future versions of macOS will not include Python 2.7 specifically. So no Python, but especially not 2.7 is what they're telling us. The important thing is then that means that you will not be able to run Python scripts. You won't be able to rely on being able to run Python scripts on an out-of-the-box Mac. You take a Mac out of the box, it may not be able to run a Python script out of the box. So how do these announcements affect you? You need to prepare. You might be thinking, I'm a Mac admin. I don't do any scripting. I don't touch Python, so this doesn't affect me at all. Real easy. I have bad news for you. There are a bunch of tools that are commonly used in the Mac admin world that are written in Python either entirely or at least have Python in some part of them. Some of them are Python 3 ready today. Some are in progress. The work is being done. Some, not at all. There's been no 3 work done on them at all. So if you use any of these products, or if you use any Python products at all, because there's tons more that I didn't list here, you need to check to see, is it getting ready? Is it ready for Python 3? Is it getting ready for Python 3? But there's something more to worry about. Who uses these? None of us, right? This is not something we use, right? This is an Apple installer package. And as part of an Apple installer package, they can contain scripts. Many third-party software has pre-install scripts, post-install scripts embedded in the package. These scripts can be compiled executables, but most of the time they are written in a Unix scripting language. And Python is a Unix scripting language. Fortunately, not too many important vendors use these in their scripts at all, so that you don't really have to worry about it, just weird edge cases. An example, Office 2011, it's full of Python scripts. There's 389 scripts in here, right? Virtually every single sub-package in an Office 2011 installation has 5 Python scripts. So this particular update has 48 sub-packages that contain Python scripts. So there's a total of 240 Python scripts in this one package. But, you know, thinking, I don't use Office 2011 anymore, right? Everybody's off that. Nobody's using Office 2011. So we don't have to worry about that. Oh, wait. Does anybody use Office 2019 or Office 365? Still Python in some of those. Here we go. This is Word 2019-1629. There's a Python script called docutil inside it. That's not going to run when Python goes away. But fortunately, they've written this post-install script in, it's a shell script, and it calls the Python tool in a way, see it's right here, it's defined the docutil path, and it calls docutil a whole bunch of times. I'm guessing this is to put, well, actually I shouldn't guess, it's putting Word and Excel and all that sort of thing in the doc, whether you like it or not. But if Python goes away, this script will fail, but they're exiting 0 anyway. So this will probably continue to work even after Python goes away. It's just that docutil will not do what they wanted it to do, but you probably didn't anyway, so great. But, you know, there probably aren't very many other major vendors that use Python in their installers, so, you know, we're probably okay, right? Would it shock you to discover that recent Adobe Acrobat DC updaters rely on several Python scripts? It doesn't shock me. These are absolutely essential to the install process. If Python isn't there, these scripts won't run, and Acrobat will not be updated. So, to get a kind of an idea of the damage you might be looking forward to, Armin Briegel, he's a Mac admin and a writer. He's written several books. Actually used to live here in Southern California. He's now living in the Netherlands. But he's written a nice little tool called PackageCheck, and you can point that at a package, or better yet, a folder full of packages, and it will go through and it will tell you what types of scripts are in there and what their shebang line is, that would let you know if it's a Python script or a Perl script or whatever. And it will let you kind of get an idea what the potential damage is here when Apple yanks Python and Perl and Ruby and Bash from macOS. So, if and when Apple yanks Python from macOS, what do? Well, probably you're going to have to provide your own Python. So how are we going to do that? Well, the easiest and safest thing to do is you go to python.org. That's the official website for the Python Software Foundation. They have a download link, and you can download the current releases of Python. They've got a link right now. Python 3.8 was released just this week, like maybe yesterday. But you can download Python 3, you can download Python 2, and you can install those, and now you have Python once again. There are a few issues you need to be aware of, though. All of these installers install to Library Frameworks Python Framework. The Python 2 installs to that path, the Python 3 installs that path. That means you can't have both at the same time. You have to choose. That probably wasn't a big deal when Apple provided Python 2. Well, like you could install Python 3 in Library Frameworks Python, now you'd have both. But when Apple yanks Python 2, you still might need both. How do you install them both with these packages? Answer is right now you can't. When you think, well, I'll just install it and then I'll move it somewhere. I'll rename it, I'll just call it Python 3 Framework, or I'll move it to another path. That won't work either. That will break these frameworks. And that's because they have sort of embedded in them absolute path references to other elements, and so when you move it, it can't find those other things, so they're not where it's expected to be. That also, think about that in terms of, we've got this Library Frameworks Python framework, we're downloading a package from the internet, from an official place. Who else might do that? Power users or developers, that use the machines that you manage. So let's say you decide, well, I'm going to just install Python 3 using this package. I'm going to install it in library frameworks Python. And then a developer or power user downloads Python 2 and installs it there, and now they've broken what you did. And then the last thing to think about is, unlike Apple's Python, the official Python from python.org does not contain any of sort of the nice things that many Mac admins use when they're using Python with macOS, and that includes PiObjectiveC, the extended attributes command, which allow you to manipulate things like the com.apple.quarantine flag on files, and just other Apple bits. They're not there. It's very generic Python, almost the same that you would get on Linux or any other OS. So I created an alternative to kind of help with this problem, and it's available at this GitHub site. I actually created this originally so that I could run Python when in the recovery boot, because recovery boot doesn't have Python at all. And there were certain tools I wanted to be able to run, and so I wanted to have a disk image that contained the Python framework and my additional tools. But it turns out that now that we know that Python's going away from the real macOS, that this can be useful for that as well. So what this script does is it actually downloads the Python package from python.org, so it's the exact same, it starts with the exact same official package that you get from Python Software Foundation, and then it modifies it. It changes it so that it can be relocated, so that it will work if you move it to other places in the file system or if you rename it. And it also adds in some additional Mac-friendly stuff like PiObjectiveC and the Xadder module. Not particularly interesting to look at, but there's a README on the website. You can get help for the command, --help. It always amazes me how many people never think to try that. They're like, I don't know how to use this, and then you point out, hey, did you try help? No. Hey, look, this has a help page. Again, kind of boring to look at, but here we look at, here's the framework. We give it a version that we want to build. We want to build the 3.7.4 version, and we want to install it out on the desktop. And it does not do it this quickly. Takes a lot longer than that. And ta-da, there's the Python framework on our desktop. Well, maybe not your desktop. That's my desktop. No, I'm lying. That's my desktop. Anyway, so the other thing is that it's a framework, and so the stuff is kind of buried inside it. So the actual Python executable that you would use to run the script is buried kind of deep inside the framework. So you might want to make a symlink somewhere to make that easier to get to. So in this case, I've got the Python 3 framework out in user shared. So I make a symlink user local bin Python 3 pointing to that actual binary. That's actually probably the worst place to put it, because again, that's a place that somebody else is probably going to overwrite it, so you might want to pick a different location. I don't know what location to tell you. I think a lot of people are saying, I'm going to put it in library, whatever my organization name is, and stick it in there. Find something that works for you, but that is not likely for developers or power users to overwrite what you're doing. One of the problems with somebody suggested, hey, let's do something sort of generic that any organization could use. Let's have an installer package that puts it in library management Python framework. And we got to talking and we realized those developers and power users, they see that library management folder, that's the first thing they delete. So, you know your environment, figure out something that works for you. This also lets you, have multiple versions. You don't have to be called Python framework. You can have Python 2, Python 3. So if you're a developer or an admin who scripts in Python, you have some more preparation to do. You need to figure out how your code is going to survive this transition. What's going to happen to your code when Apple yanks Python out of macOS? So you have some choices. You can stick with Python 2. You can move to Python 3. You can move to a compiled language, or you might be able to convert your scripts to shell scripts. Any of these might be a valid choice depending on the specific situation. For example, sticking with Python 2 is the simplest one. You don't have to make any changes to your script at all. Apple yanks Python out of the OS, you put your own version in there, you just keep on going, right? So why don't we just do that? Well, in fact, you could start on this even today. Why wait for Apple to yank Python? Put your own Python in there now. Start pointing your tools to that. But the big risk to this, at least long term, is the fact that Python 2 is end of life in January 2020. So this means that if there are security vulnerabilities found after that time, there's not going to be any patches. So imagine, where it's June, July, something like that, and some major security vulnerability is found in Python 2. And now your security folks are screaming at you, you've got to uninstall Python 2 from all of the endpoints because it's insecure. And now you're in full-on scramble mode because you didn't make the preparation for moving off of Python 2, but you now are under the gun to get it out of there. Now, don't tell those same security people, well, do tell them. I just want to see what their faces look like when they ask you to remove Python 2 from, Apple's Python 2 from your SIP protected OSs and your read-only system volumes, and you tell them, I can't do that. They won't understand that at all. Yeah. This is another possibility. If you have scripts that you've written in Python because you like Python better or because you're more productive in Python, that's true for me in both cases. I'm much more productive in Python than I am in Bash or regular shell scripts. But there are a lot of simple scripts that could be converted back to shell. They don't need the overhead of Python. They'll probably run a bit faster even. So you could do that. The one thing you don't want to do is don't convert them to Bash scripts because Bash itself has been deprecated in Catalina and Apple may remove it in a future version of macOS. We don't know, but let's assume the worst and prepare for that. Moving to a language. That's probably the hardest of the options, but it might make sense in certain circumstances. Here's an example. So I have a tool called PyCreate user package. And what it does is it allows you to create a package that will, when installed on a machine, will create a user account. And really commonly this is used during bootstrapping a machine to create a standard local admin account. That's how I use it in my organization. There's a package. It's installed. Now I've got a local admin account with a known password, known UID, all that good stuff. But inside the package, it has a post-install script. And that post-install script, when it's creating the user, calls a Python script that uses PyObjectiveC to call Apple Open Directory APIs. So the way the user is created is we're calling Apple's APIs to do it. And at the time, the easiest way for me to do that was to do it from Python using PyObjectiveC. But if Python goes away, this isn't going to run. The script is going to fail. So we'd either have to make sure that Python was installed before we try to create any users. Remember, this is often used in a bootstrapping environment. Or we'd have to include an entire copy of Python inside the package and keep that up to date. And I didn't like either of those options. The first one sounded like that's something you'd have to communicate to everybody and people would make those mistakes and they wouldn't understand. And then the other part where the other option, keeping Python, now you've got this like super huge package to create a user because it has an entire copy of Python inside it. So neither of those sounded great. But I got to thinking, and that the Python tool that creates the user and it's calling these Apple APIs, it's mostly PyObjectiveC. There's very little pure Python in it. It's a bunch of Apple API calls that just happen to be translated into Python syntax. So what made sense to me, if I wanted to get rid of the dependency on Python for the actual install of the package, was to take this tool and just convert it to regular Objective-C. Get rid of the Python, just write it in regular Objective-C, compile that. And so now our post-install script instead of calling a Python tool, it calls a compiled Objective-C binary, and now there's no dependency on Python in order to create these users. But there's still one problem. We'll get to that eventually, getting rid of the bashisms in this script. Hopefully we have a little more time on that, but I don't know. It's always something, right? Apple keeps us busy. And that brings us to our last option, which is to move to Python 3. And this one probably makes sense most of the time. That's what we're going to do with Monkey. Well, Monkey is in that process right now. There are early alphas that people are testing. And so what we've done is Monkey now includes its own Python framework inside the user local Monkey folder. And there's a symlink at user local Monkey Python that points to the binary inside that framework. And now all of the tools inside of Monkey that are written in Python, we've changed the shebang line to use user local Monkey Python instead of user bin Python, which would be Apple's Python. So now we're completely independent from Apple's Python. Apple can yank Python, and it doesn't matter. And this is Python 3, so we're hopefully forward safe. We'll have something that it continues to be developed. So that's great. So let's say I've laid out these options, you've looked at these options, and you've decided, yep, I'm going to move my code to Python 3. This, of course, is a really big task. And in most cases, Python 2 code will not run in Python 3 without you having to make changes. So you're going to have to, you can't just change the shebang line from Python 2 to 3 and it'll just work. There's stuff you have to do. So we've been looking at a lot of text and code, and our eyes need a break. So let's watch what happens if you try to get to Catalina without adequate preparation. And there's supposed to be sound, but that's okay. You don't really need it. Yeah. See, for those of you who aren't aware, Catalina is actually not that far. It's across the ocean here. And if you have ice powers, you could probably run really fast and freeze the ocean as you got there. But if you're prepared, maybe you would just have a boat. But she didn't have a boat. Anyway, so we're going to convert to Python 3. How are we going to do that? So here's a few of my recommendations for approaching the task. You should read and bookmark the Conservative Python 3 Porting Guide. This is a great little read. The concepts here, it's very opinionated, but basically it's like, what's the least amount of work I can do to get my Python 2 code running in Python 3? So they're not being like super, this is the correct way to write code in Python 3, you should not use this old style of, no, they don't care. It's what's the bare minimum I can do to get to Python 3. And the great thing is if you do it right, your code runs in both Python 2 and 3, which helps with this transition because it's no fun to have to maintain two versions of your code base, to have, here's my Python 2 code, oh, there's a bug, I got to fix that there. Oh, did I carry that bug over to the 3 version? You want one version. So read that. You need to get a copy of Python 3 in order to start doing your testing. I recommend using my relocatable Python tool to get that, but you don't have to. You could get the one from python.org. You need to install Python 3 versions of any third-party modules you use. So if you use the request module, that's super common. Admins use that all the time. That might be installed for your Python 2 installation. Well, you need the Python 3 version of that installed over in your Python 3 installation. And then here's your magic wand. You want to get this tool. This tool is called Python Modernize, and it will help you. It will hold you by the hand, and it will help you convert your code so that it will run on Python 3. And that's our goal here, is to take Python 2 code, do what's needed to get it running on Python 3 while still maintaining compatibility with Python 2. so we can continue to use both versions of Python until we're ready to cut over. And of course, you're going to be doing lots of make changes, test, find a problem, make some more changes, test, find a problem. This is going to be an iterative process. You don't expect that you're going to push one button, all your code's going to get converted to Python 3, and then you can move on to other problems. Wouldn't that be nice? That's not where we are. So these two tools can help you convert your Python 2 code. You could install these yourself using pip. Pip is one of the common tools people can use to install additional Python modules. But if you don't like pip or you're uncomfortable using it, I did create an Apple installer package that will install these tools for you. I actually created this last summer at the Penn State Mac admins. We had a Python 3 convertathon. We were trying to convert as many tools as possible. And so I created some tools that people could use. And so this is one. This is a package that will install Python modernize and PileInt for you so that you can, you don't have to worry about learning how to use pip and all that sort of thing. So let's take a look at Python modernize. You pointed at a script you want to change. So here I'm going to look at a monkey package script, monkey package tool. And I say Python modernize monkey package, and it goes through it, and then it prints out in Unix diff format the changes it thinks are needed to make this compatible with Python 3. So for example, it wants us to replace, so if you've never seen Unix diff format before, minus means take this line out, plus means put this line in. So basically replace the first line with the second line there. So we're going to replace our reference to base string. Base string is a class that doesn't exist in Python 3. So it's saying that's going to cause Python 3 to choke and die. So replace it with 6 string types, and that is a sort of a wrapper class that's in the 6 module that does the right thing whether you're in 2 or 3. 6 is a third-party module. However, Apple includes it in their version of Python. So it's already there for Python 2, Apple's Python 2. And my relocatable Python tool also installs a copy of 6 in the framework that it builds. So if you use that, you will have 6 available in both environments. It finds another thing that it thinks we should change. The keys function for dictionaries has changed behavior in Python 3. We'll talk about that a little bit later. And what it's suggesting is if we wrap that with a list function, we'll get the same behavior whether we're in 2 or 3. So we're just, again, it's finding here's a difference, and here's how you can write the code so that it will work the same in both versions of Python. So if you're happy with the changes that it suggested, or more likely you don't understand them at all and you're just hoping that it's doing the right thing, you can use the -w flag and say Python modernize W for write, and it will actually write the changes back to the file. So instead of printing out what they should be, it'll just make the changes and write them to the file. Second tool, PileInt. This is a tool that has use outside of this. It's a tool that Python people often use to check the syntax. You can run PileInt against some Python code, and it will tell you things about the syntax. Oh, this line's too long, or you have too many branches, and it complains about variable lengths and all sorts of stuff that annoys the crap out of me. But it occasionally will find bugs, and you can give it an additional flag, --p Py3k, because the original name for Python 3 was Python 3000. So Py3k, and it will look specifically for Python 3 issues in the code. So again, we're going to run that against the monkey package tool, and it finds one thing. Hello. And this is actually one of the exact same things that Python modernize found, and that there's a reference to the base string class, which is no longer available in Python 3. Now notice it doesn't tell you what to do about that. It doesn't have any suggestions about fixing problems. It's just telling you, hey, this syntax isn't going to work in Python 3. So yes, there are tools that will help you move your code from Python 2 to Python 3. So why don't we take a look at some of the very common changes you will have to make when you're moving your code from Python 2 to Python 3. This one, the print statement has changed. So in Python 2, this is what print looks like. Has anybody programmed in BASIC? It looks exactly the same, right? Print and then the stuff in quotes, right? In Python 3, the benevolent dictators of Python thought this was too ugly, and they thought print needs to be a function like everything else. So the syntax looks different. But we have a little trick up our sleeves. In our Python 2 code, if we do this at the beginning, now Python 2 can use the new Python 3 syntax for print, which looks like this. So it's not a huge difference. Basically, it's a function, so now everything has to be inside the parentheses. Not that big a deal. Was it worth breaking everybody's code for that? I'm not quite sure, but you have to ask Guido. There's another syntax with print that the change is a little less obvious. In this particular instance, this is in Python 2, we're printing to the standard error output instead of standard out. In Python 3, it's an additional parameter to this print function. And I put this from Future. You don't have to put that in front of every time you call print. That just needs to be once at the beginning of the file. But it has to be there in order for Python 2 to be able to use Python 3 syntax. Strings versus Unicode versus bytes. This is super, super confusing. And this is probably the #1 set of unresolved issues in all the code I've been moving to Python 3 is I keep finding places where, oh, screwed that one up, or I didn't do that one right. Let's go into this a little bit. So in Python 2, there are 2 string types. There's a simple string type, which uses 7-bit ASCII characters. The characters that red-blooded Americans use to write their language. No, none of these funny characters with, ennyas and umlauts and stuff like that. That's not American, so we didn't need that. Which is actually odd because Python was originally developed by Guido van Rossum, who is from the Netherlands, but it's still a very American approach to strings. There's a second string type, Unicode, which can then represent all of the wonderful types of characters that are available in human language, including the wonderful human language known as emoji. Those can all be included in strings, but it's a different type. There is a superclass, base string, we talked about that earlier, that is the superclass for both string and Unicode. And it's really useful in code if you want to know, is this thing a stringy thing? You ask if it's, is it of type base code, and then or base string, and if it's either a simple string or a Unicode string, the answer is true. Yes, it is string-like. Python 3, there's only one type of string, and that's the Unicode string. So all strings are Unicode. There's still a need, though, for sequences of bytes, and so there's a new type called bytes, and it's kind of like the simple string type in Python 2, but it's not exactly. And this is where the confusion starts really piling on top of each. There's also, because these are actually 2 different things, they're not bytes is not a simpler form of string. There's no superclass for that. So that's why base string doesn't exist in Python 3. So some examples here, and hopefully these will get clearer. If they don't, fine. So A, we're going to assign a simple string to A, and the type of it, str, string. For B, we use this little Pythonism. If we start the literal with a U, we're telling Python this is Unicode. And see, I made it really Unicode-y here. That's I sweetified hello, right? That's sort of the IKEA version of hello. So, so B is type Unicode. And then just for backwards compatibility, Python, recent versions of Python 2 have added this B prefix to a string literal to tell Python that this is a sequence of bytes. But there is no sequence of bytes in Python 2, so it just turns into a string. Confusing? Wait, it gets more. Python 3, remember, Unicode goes away. So if we just do a plain string, it's type string. If we do a Unicode string, it's still type string. If we put the B prefix, it's bytes. So that's a little different. And here's where this starts getting even more confusing. In Python 2, they all look the same when I print them out. So we're going to say A, simple string hello, B, Unicode string hello, C, bytes hello. And when I print them, hello, 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 they all look the same. I can't tell the difference. Python 3, do the exact same thing. Simple string, Unicode string, they're the same thing now. Bytes. Oh, it lets us know, hey, that last thing is not a string. It's something else. It looks like a string, but it's not a string, and you need to pay attention to it. So that's a little, that's, in my opinion, that's good, because it helps you notice subtle bugs you would miss before when everything looked the same. And here's one of those bugs. In Python 2, I can add together, I can concatenate together a simple string and a Unicode string. So the simple string, hello, the Unicode string, world with a funny O, and if I say, hey, print A and B, Python says, sure, that's fine, I don't care. Put those together, hello world, great. Python 3, however, do the exact same thing, and we print them, and it says nope, because it doesn't allow you to combine a random collection of bytes with a string, because they're two different types. So this helps you find these bugs, but this in itself can be a bug if you were relying on the previous behavior, which is really easy to do. And here's one place where it happens. I find this sort of thing in my code all the time. So again, Python 2, we're going to import subprocess, and then we're going to use it to get the output of the ls command. So we're going to ask ls to list the contents of my home directory, and then we're going to print that output. Okay, that's pretty straightforward. It's the folders inside my home directory. We'll do the same thing in Python 3. Exact same thing, no changes, except the print syntax is a little different. And we get something back completely different. It's because the output from most of these command line stuff is not strings, it's a sequence of bytes. And we have to decode those bytes into strings. So the encoding generally for stuff that you're doing in the terminal is going to be UTF-8. So I have to print output decoded as UTF-8, and now I get my strings back. These are real subtle changes that if you're not aware of when you're converting code, will end up biting you in the butt, because you think you have a string, but Python 3 says, no, that's not a string, that's a sequence of bytes. You need to do something else with it. Dictionaries and lists have different behaviors in Python 3. There's lots of different behaviors. I'm just going to touch on a couple here. In Python 2, we have a simple dictionary here, we're calling it inventory, and it's the number of kinds of fruits that we have. So I've got 1 apple, 2 bananas, and no oranges. And I can use a for loop, and I can go through the keys of that inventory, and so therefore I can print the name of the fruit and then how many I have. So if I run that, I get back orange 0, apple 1, banana 2. So the answer is correct, but notice that the order is different. I assigned apple, banana, orange, but when I go through the dictionary, it comes back orange, apple, banana. And that's because dictionaries in Python 2 are not ordered. They have no order to them. They're somewhat random. In Python 3, that's changed. Same code, assigning the same dictionary. We're going to go through it the exact same way, but it comes back in the same order that we assigned it. So Python 3 dictionaries do preserve order. Another difference. We're back to Python 2 again. Same dictionary. So I want to get a list of keys, the keys for the dictionary, which would be the names of the fruits at this point. So I get orange, apple, banana. Great. Now I want to print the first one, the first key or the first fruit. So print inventory's key subscript 0, because remember Python lists start with 0, and orange. So that's what I expect, right? The first key is orange. Of course, if I thought that the keys were ordered, I'd be confused because I thought the first key was supposed to be apple, but they're not. At least it works. It doesn't crash, right? Now, if I go to Python 3, same inventory. If I print the keys, I get something slightly different back. I see the apple, banana, orange, but it's wrapped around this thing called dict keys. What is that? I don't know. So I'm just going to ignore it. Keep going. I'm going to print inventory keys 0 because I want that first item, and nope. So what's happening here, and this is what I'm going to tell you right now is not technically absolutely correct, but the idea is there. What you're getting back when you ask for the keys is a view object, or is literally a view object, and it's very memory efficient. So instead, let's say this dictionary had 10,000 items. So instead of having to allocate enough memory to give you all 10,000 items at once, it tells you, I know these items, ask me for them. And if you ask you, give me the next one, it would say apple. Okay, give me the next one, it would say banana. Give me the next one, it would say orange. Give me the next one, I don't have any more. So it's a much more memory efficient way to return large groups of data. And that's how Python 3 does this by default. But it's not a list. It's a special object that knows how to iterate through a list. So in order to get the same behavior that we had in Python 2, we have to wrap that in a list function. So we're saying, hey, look at this view object, give me the list of things that are in it, and now we get the same list that we saw in Python 2, and we can do the same thing with the subscript to get the first item, and it's apple. Again, subtle differences, but it's important to know them so that when you start seeing these errors in your code as you're converting them, you go, oh yeah, I remember this, there's a change here in how this behaves. And of course, there are a lot more conversions that you will have to make. And one of the nice things is there's yet another cheat website, Python Futureorg, compatible idioms. There's tons of stuff here about the differences between Python 2 and 3, and they give you multiple ways to sort of bridge that gap so you can decide what works for you in making the code both Python 2 and 3 compatible. It's a great site. I keep that bookmarked as well when you're doing your conversions. So I've thrown a lot of resources at you for this. So I've collected them all together in one place. Links to a lot of these tools, links to a lot of these websites, that sort of thing. You can get to them here. Obviously, when you get the slides, you'll also have it in text, but I know a lot of people like to take the pictures now, go right to it, and I promise this is not a Rickroll. I know I've done that in the past for people. This really does go to a website that is not a Rickroll. So you can click in safety right now. All right, so let's review a little bit. Python 2 is end of life in early 2020. Apple is removing Python soon. You need to prepare. Any questions? Okay, we'll wait for the microphone, but yes.
So when you say Apple is removing Python, is that future builds won't have it, or updating to a minor version will actually remove the built-in Python from your system volume?
I don't think we know. It could be either.
I was hoping you had more info than I did.
Nope, I have no more information.
Okay.
I really hope it's not going to happen until.
Can you speculate?
I'll speculate. I think Apple would be crazy to do it at anything other than a major release.
Okay.
You know, like if 10.15.1 suddenly yanked Python, people would be unprepared and they'd be screaming and there'd be much gnashing of teeth and wailing and that sort of thing. If they do it in 10.16, there'll still be lots of complaining, but at least there'll be like this 3 month of people going, oh my God, it's really not there this time, and people will take it seriously. But I don't know. We could get a supplemental update tomorrow that yanks it, and right? We could. I don't know. I hope not.
I've got one for you. I was playing with your relocatable Python while you were talking, and I can't figure out what to use for the shebang if I'm trying to run it from the desktop.
Well, I
Did
don't know
you?
if I can go back to that, but remember the, let's see if I can find the slide that kind of gave you a hint to what you need to do there. That's nice. We'll be here, not there, getting closer.
Yeah, I was getting some weird stuff where it was
Getting
actually
closer.
running it as if it were a bash script.
Yeah,
So.
there we go. So the, oh, why is it not up there? There we go. So wherever you put that Python framework, I mean, you could, let's say you put it in user shared. Your shebang line could be,
It could be the full
pound,
path, right?
pound, exclamation point, user shared, Python 3, framework versions 3.7, bin, Python 3,
Okay.
and it will work.
Yeah, that didn't work for me, but we could talk about
did
that
it
later.
wrong then.
Yeah.
That's right. Back there.
Would patching the scripts embedded in an install package break the install package?
Probably not. I mean, it depends on how it's being installed, right? I mean, there's a lot of confusion around gatekeeper and signing and notarization, that sort of thing. If the package is being installed by, say, Jamf or Monkey or FileWave or some automated system, not a problem. It would probably break, if somebody double clicks the package in the Finder, now the signing's all broken and they'll get these horrible, something terrible has happened sort of thing, or that the thing's not signed at all. I really hope we don't have to do that, because once you start down that path, you own it forever, right? I think we need to be pushing to the vendors, like Adobe, did anybody tell you that Python's going away? Microsoft, at least on that one I showed most recently, it probably won't break, but the Adobe one definitely will. All right. Going, gone. Thank you, everyone.